Now we'll discuss about the potentiometer. Actually, it is a device, integrated device you can say. It is used to measure the potential difference of a cell, and it is also used to measure the internal resistance as already we had discussed. And sometimes it is also used to calibrate the ammeter or the voltmeter. Now see its construction. What is the construction? Actually, it has a wire of length 4 meter to 12 meter. 4 meter to 12 meter like this. So one line is of 1 meter. It is fitted on a wooden platform, and a wooden scale is also used to measure the length. Okay, it is the meter scale from 0 to 100 centimeter. Okay, and this is a very long wire. You can see the wire of 100 centimeter connected in series with the help of the strip, metallic strips like this here. Metallic strips are here like this. Okay, so these are the, you can say, the 2 points A and B. Okay, so this is the potentiometer. Now see what is its principle, how it works. Okay, now see its principle. You know V is equal to IR. Okay, and R means it is the rho L upon A, or you can say it is I rho upon A into L V. So if the uniform current is there, that is the current is constant, area cross section of this wire is constant, then in other words you can say V potential difference across the length of a wire is directly proportional to its length. Okay, V proportional to N. It means, see what is its principle. It's very easy to remember using this formula, using this relation, that the potential difference across the length of a wire is always directly proportional to the length of this wire. Okay, so V proportional to L. Okay, remember I is uniform, I is constant, and area of cross section of the wire is also constant. So taking both as constant, we can say V proportional to L. So by changing the length, we can measure the potential difference. Okay, so this is the principle, very important for exam point of view. And this value is known as the potential gradient, because if you write here V is equal to a constant value KL, where K, you know, V upon L is equal to, what is this? It is the potential gradient, and is the potential difference divided by length. So it is the potential gradient. So this value is the potential gradient. So based on it, the concept of the potential gradient, we can tell about the sensitivity of the potentiometer. See what is the sensitivity of potentiometer. Actually, to increase the potentiometer, it is the V upon L should be very small. It should be small. Okay, should be small. So to increase the sensitivity of this device, we have to decrease, or we have to take the value very small. So how this situation is possible? How this situation is possible? There are two methods. First method is that L should be very large. Okay, L should be very large. And second is, if we increase the current, so by V upon L here, so V upon L is equal to I. So by decreasing the I, okay, if you decrease this value, so V upon L will also decrease. So there are two methods to increase the sensitivity. Sensitivity means that is the smallest value which you can accurately by the small change of the length. Okay, it means if you change the small length, then the potentiometer should be sensitive, should be capable to measure the potential difference accurately. That is the potential meter working. Okay, now sometimes we think we can measure the potential by using the voltmeter also, but question arises why we say potentiometer is better than voltmeter. Okay, it's a very good question. See why the potentiometer is better than voltmeter. Okay, see some reasons are here. We can compare and you will understand this comparison when you will study about the working, or when you will learn about the applications of the potentiometer. So first you can say it measures the EMF. It measures the EMF of cell accurately, you can say. Okay, potentiometer measures accurately, and it measures EMF of cell approximately. Okay, not exactly. Now see the second point. While measurement, you can say while measurement, it does not draws any current. Okay, it does not draw any current, and here it draws some current. Okay, some current. Okay, and third, you can say it is based on the null deflection, means deflection will be zero in the galvanometer. So it is based on null deflection method, you can say. Okay, and it is based on the deflection method. It is based on deflection method. Okay, this is the another comparison, and one more compare you can see. It can be used for the various purposes. Various purposes means you can calibrate the voltmeter, ammeter. You can we can measure the potential difference, as well as we can find the internal resistance of the primary cell also. Okay, so various purpose, you can say. So next fourth is here. It can be used for various purposes. Okay, and it is used only for the potential difference. So it can be used only to measure EMF or potential difference. Okay, so this is the comparison. So that's why potentiometer and the voltmeter, if you compare, the potentiometer is better. Now if it is asked in the different way, that is the why the potentiometer is better, why it is superior. So superiority of potentiometer over voltmeter. Okay, see there are mainly two reasons, clearly you can see. See in galvanometer we use in potentiometer a galvanometer we use. Galvanometer, that is a 0, 1, 1, 2, 2 like this. And here in in the potentiometer we see the zero deflection, means no current flows in that condition, so zero deflection. And in voltmeter there is a deflection, that is the 1, 2, 3, 4 volt, etc. So we count the number of divisions. So counting of the number of divisions in the voltmeter is not so accurate as to measure the zero. So we can see zero clearly and distinctly, you can say the accurately also, but the in voltmeter you can't read accurately the number of divisions, so there may be some mistakes. So that's why it is superior, that is the potentiometer is superior. And see the another reason, we know for the ideal voltmeter, for the ideal voltmeter R should be infinite. That is, I should be zero. No current should flow in that condition. And because potentiometer is based on the zero deflection method, so that's why it is the ideal voltmeter. Okay, so you can say therefore potentiometer is ideal voltmeter. Okay, ideal voltmeter, but the actual voltmeter is not that, because it draws some current always, clearly. So these are the basically two reasons we say potentiometer is always superior than voltmeter. So today we had discussed about the basic of the potentiometer. In next video we'll discuss about the applications of the potentiometer, in which we'll discuss the two applications. First, to compare. First application we'll discuss application to use, to discuss, you can say. Okay, first to find the internal resistance, and second to compare the EMF of the two primary cells. Okay, so we'll discuss in next video. Thank you.